1 Dynamics, example 4. In this example, we're required to draw a diagram to represent the forces before we actually start to do the question. We've got a particle of mass 5 kilograms. It's being pulled along a rough horizontal table. We tend to show that tables are rough by doing some diagonal lines like that. It's being pulled along by a horizontal force of magnitude 20 against a constant frictional force of 4 newtons. The particle is initially at rest, and we've got to find various things about this particle. So it's accelerating to the right. We don't know the acceleration at the moment. Now, they haven't actually told us any vertical forces, but we know that this particle will have weight, and in that case it's 5 kilograms, so that's 5g. If you remember, weight is mg. That's from example 1. So in this case it would be 5g. That would be balanced out by a normal reaction, which we tend to call r. So first thing, we have to find the acceleration of the particle. Well, we can do F equals ma to the right. So the forces acting from left to right are 20 pulling the object forward and 4 newtons resisting the motion of the object. So that's a resultant force, and that's equal to the mass, which is 5. Remember, mass and weight are not the same thing. Weight is a force, and something would have the same mass if it was on the moon, but it wouldn't have the same weight. So it's really important. The mass is 5, the weight is 5g. So in here, mass is 5, and acceleration, we don't know. That's what we've got to work out. So solving this, 16 equals 5a. So a is 16 divided by 5, which is 3.2. That's the answer to part A. Part B, the distance travelled by the particle in the first 4 seconds. So t is 4. We know that the particle starts from rest, told us that in the question. We know it's got an acceleration of 3.2, and we want to know the distance. So this is sounding like a kinematics question. I think the best formula to use would be ut plus a half at squared. So S would be 0 plus a half times A times T squared. And if we work that out, that works out to be 25.6. Finally, part C, the magnitude of the normal reaction. This is the normal reaction, R, between the particle and the table. Anytime an object is resting on a surface, there is a normal reaction. The table pushes back and holds up the object. So we know that there's no acceleration vertically. This particle is not moving up and down, it's just moving from left to right. So we know that the force upwards must equal the force downwards. So R is equal to 5g, and 5 times 9.8, that works out to be 49 newtons. And so that's a normal reaction.